Let's start with an example of a direct proof. A direct proof means you begin with a hypothesis P, you do whatever steps you need, and you reach the conclusion Q. So you're literally moving from P to Q. That's what makes it direct. The statement we'll prove is, the sum of two odd integers is an even integer. This statement is fairly typical of a theorem. It's not necessarily phrased as an if-then statement. So let's identify the hypothesis and the conclusion. The hypothesis is, if m and n are odd integers. The conclusion is, the sum of m and n is even. So if m and n are odd, then m plus n is even. Okay, phrasing it this way gives us tools to work with. I know how to describe odd and even integers. So let's start our proof by assuming that m and n can be written in the typical fashion of odd integers. So namely, we'll suppose that m can be written as 2j plus 1, and n can be written as 2k plus 1, where j and k are integers. Therefore, 2j plus 1 and 2k plus 1 are not divisible by 2. Both of them have a remainder of 1 after division by 2. Alright, now that I actually have expressions for m and n, I can add them together. And let's see what we get. M plus n is 2j plus 1 plus 2k plus 1. We can combine some like terms, and we get 2j plus 2k plus 2. Notice all of those are divisible by 2, so we can factor the 2 they have in common out front, and what we're left with is an even integer, because it's 2 times j plus k plus 1. So this number is divisible by 2, therefore m plus n is an even integer whenever m and n are odd. This was an example of a direct proof.